Welcome back, everybody. Today we're going to do take a look at some periodic functions. Trig functions are periodic functions. So before we get into the details of what sine and cosine are, we're just going to take a look at what does it mean to be periodic. All the different parts of a periodic graph and their definitions and identifying this stuff. So in this picture, where obviously there's not a picture there, diameter of a wheel is 24 inches and it rotates once every 4 seconds. We're supposed to draw left to right 2 rotations. So assuming that this is the ground, right? So this wheel rotates every 4 seconds. So I guess we're supposed to picture like something painted on the wheel or some sort of mark on the wheel where we could actually measure the height of that spot as it spins around the wheel. So it starts at 0 is the height, and we know that the maximum height is 24 inches. So I'm just going to go, okay, this is 24 inches and make that 12. So this is basically the height of the wheel in inches. And then left and right is going to be time. And because I have such a long graph, I'm going to make this every other 1 second. And then we have to do it for 2 rotations, so we have to go up to 8. So we know at 0, right, the height of this paint spot or the spot on this wheel is 0. Every 4 seconds, it goes all the way around. So at 2 seconds, it's going to be as high as it could be, which is the diameter. So at 2 seconds, it's going to be at 24. Back at 4 seconds, right, it's going to be all the way back down again. Well, halfway between 2 and 4, the spot that we can measure will be right about there, which is the radius. And the radius, of course, is 12. So at 1 second, it'll be a height at 12. Back over here where it's 3 seconds, right, this would also be a height at 12 off the ground, let's say. And so now it's back to 4. And then the entire thing repeats again. And this would happen every time the wheel spins around. So it looks like an odd seconds, it's at 12. And at 6, it would be all the way back up its maximum. 8, it's back down to 0 again. And so you can connect this smooth or pointy, however you want to connect it, but that's what a periodic graph is. There's only so many values, like this has very few values, and they just keep repeating. And the repeating part is very predictable. Like we could predict this out and we would know, let's say at 12 seconds, you could predict that the height would be 4 or 0 again because 8 plus 4 more was back down to 0. We could do the same thing with really any spot on here. We don't need an equation. We can just figure it out based on the pattern. So one entire cycle or one spin of this wheel means that all the numbers repeat, or values, answers. So that's how long it takes for everything to repeat. A period is the same kind of a thing, but graphically we want to look at the period. Period goes from high to high or from low to low because that's what it takes to have all the numbers repeat. Like if we look at all this, every single number got repeated. It had to go, the graph had to go all the way down and then come all the way back up again for it to be repeated. So it has to go all the way up and then come back all the way down. Or if it starts up, it has to go all the way down and come back up. So a period is measured from max to max or min to min. And it's up to you. You can pick, because maybe some graphs are easier to read low to low, some graphs are easier to read high to high. What you want to be careful of is measuring it from zeros, because if we only measured it from 0 to 0, well, we missed out on a lot of values. So be careful with going from 0 to 0. Now the amplitude is how far up does it go. So from like the middle, how far up does it go? So we would measure the amplitude from here because it goes up and down the same amount. It goes up 12 inches and down 12 inches. So the amplitude must be measured from the middle, not from necessarily from the axes or anything else, just from whatever its middle is. And so it's kind of hard to find sometimes. So we have a nice formula for it. It's just 1/2 the max minus the min. So the amplitude is a measurement up and down, basically from the middle up, and the period is measured horizontally, spaced left to right. So we're just going to take a look at a few to practice doing period amplitude. Oops. Sorry about that big line there. So it says for each function, identify one cycle in two different ways. So remember, a cycle is where all the numbers repeat. A cycle is the same thing as the period. So for example, we could measure this from high to high. So we could just put a box from high to high. We could also go from low to low if we wanted to. So another way to figure out this period would be from here to here. So it's up to you, whatever you think is easier to actually read or determine. We could do from -1 to 3, basically on the number line. That means it's 4 spaces, so the period is 4. So if we take a look at this one, if we wanted to go from high to high, that could be our period. Or if we wanted to go from high to high again, we could go just another square right there. So you don't have to mix it up, but there's just realize you have options, because sometimes looking at your options has a tendency to make this easier. So this graph is a little bit hard to read. These are counting by ones. I believe that's a 3. So it goes from 0 to 3. I think the blue square is probably easier to read than the red one. Now for part number 2 here, it says determine whether each function is or is not periodic, meaning the values have to repeat every so often. So if we take a look at this down here, right, we're looking at -1, because that's the y value. If you look, -1 never repeats. There's other numbers that never repeat. That was just the first one I picked. So this one is not periodic because that number doesn't repeat. Now for part B, this one is periodic because you can see the same values repeat over and over and over. So the answer is yes, it is periodic. And now we need to figure out what the period is. We can measure it from here to here because low to low. I like to start maybe if I can on 0, like this one does. 2, 3, it looks like that's a 4. So the period here is 4. You can't find the period if the graph isn't periodic. Now for the amplitude, sometimes the amplitude is hard to read. Like this one, the middle, if we cut the middle horizontally, it would be there. It is not necessarily the x-axis. So your amplitude is how far up does it go or how far down does it go from that midline. Again, sometimes the midline is hard to find, so sometimes the formula is a little bit easier to read. Again, this graph is a little bit hard to read. I believe that's supposed to be a 1. So our maximum is 1. It looks like the low point is at -2, so 1 minus -2. So the amplitude here would be half of 3, or 1.5. Your amplitude is a positive number. Here's a weird graph. It is periodic though. Like you can tell these values just over and over and over just repeat that same pattern. I'm going to use because I don't really know where that midline would be going here, I'm going to use the formula. So we have 1/2. The absolute highest point is 4. It looks like the lowest point is right on the axis, so 0, half of 4. So the period is 2. Periodic curves happen in nature. Anything that has cycles, like your 24-hour day, oceans, the moon. So lots of things we can see that have sort of repetitive values. That's all we're looking for. So here we have a sound produced by periodic changes in pressure called sound waves. An oscilloscope shows the periodic changes. A sound wave has a period of 3 seconds with an amplitude of 2. Draw 2 cycles of this graph. Amplitude of 2 doesn't really tell us where to start. I'm going to start at 0, so I'm just going to start right here. So we know that it goes up to 2. I don't know why I went all the way up to 3. And we know that 1, 2, 3 seconds, all the values repeat. So I'm going to have to draw it twice. It does not say if it starts at 0. It doesn't say if it starts at the top. So I don't know where it starts. So I'm just going to start mine at 0, 0. So I know that at 3 seconds it's going to be back down. And at 6 seconds it's going to be back down. Well, exactly halfway between 1 and 3, or at 1.5, it should be at its maximum. I don't really know much else about this pattern, except to just go high, low, high, low. For number 5, we have a wave, some sort of wave. I don't know if it's an ocean wave or another sound wave. It says the cycle occurs from 2 seconds to 7 seconds. The maximum value of the function is 4, and the minimum is -4. Now this gives us a little bit more information because now we know we're going to go down below that x-axis. And so we know that the period has to occur from 2 to 7. So we know the period is 5 seconds, which is helpful because now we know every 5 seconds the answer should repeat. The amplitude is 1/2 the max, which is 4, minus the minimum, which is -4. So our amplitude is half of 8, which is 4. So they're asking us to draw 2 cycles of this graph. Well, I don't know if it starts high or starts low. I don't know anything about this, neither do you. I know that it has a maximum at 4 and a minimum at -4. The idea is that you start to see where the amplitude is your y-axis and your period is the x-axis. All right, so that's the relationship between all these graphs. And we know we have to start at 2 seconds. A particular wave occurs from 2 seconds to 7 seconds. Okay, so 1, 2, here's 2 seconds. Here's 7. We probably should go all the way back out to 14, right? Because it'll be, it says to draw 2 cycles. So I do have to go to 14. I'm just sort of looking at my graph. I think I have to move my words. I'll just make it fit. So there's 14. So I know that it goes from 2 to 7. I'm just going to say, okay, let's have it start high. And we know that the period gets measured from high to high. Right? We can start at low, but I know that my period gets measured high to high, so I don't want to start at 0. And then halfway, which would be right around, let's see, there's 5. So half of that is 2.5. So 5 divided by 2 is 2.5. And we have to add 2 to that. So at 4.5, it should be at its low point. 1, 2, 3, 4. That doesn't make any sense. 2.5 from, oh, I'm counting. So at 4, 1, 2, 3, here's 4. At 4.5 would be -4. That's better. I added the 2 and then started counting from 2, so that didn't make any sense at all. And then we know, so every 2.5 seconds it goes up, down, all the way up, all the way down. So we also know that at 14 it would complete its second cycle. And then 2.5 seconds in from 7, it would be down at its minimum again. So you can draw this pointy, you can draw it curved, it's up to you, but that's what that wave would look like. Again, so we're just trying to practice period and amplitude on these just random graphs that they give you.